enjoy explaining are the ones in which you are most interested in understanding something that you don't know, and I possibly might. So if you are capable of asking a question, then you should ask yourself to come on the stage. And, and while I'm waiting for more people to arrive, I will invite you to come to the stage. So let's see how that works out. I press a button, uh, and then I invite you to speak, and then we see if you come up to the stage. And that's how it works. Uh, so I'm inviting everyone I can see to the stage and see what happens. And because, of course, what I don't do in this room is I don't lecture on topics that aren't, in fact, questions that you've asked. Then I will lecture on a topic that you've asked, because there seems to be there's a lot of things that people are interested in astronomy, and I know many of those things. And so, oh, Frankie, hi. Hi. Welcome to the stage. Are you there?
Oh, hey.
That, hey, is that your dog?
Yes.
And are you white water rafting, and he's wearing a life preserver?
No, she just turned 10 and I'm very protective and she requires a life vest when we spend a lot of time in Central Oregon and because yeah, the stargazing is pretty good up there. Um
Uh, I was in Bend, and in Bend there's a river, and people sort of
yeah.
board down the river. Is that where you are, or someplace else?
I will be day after tomorrow, but that's the Deschutes River, yeah.
Yes, yes.
Uh-huh.
My grandson was born in Bend, and as from the total eclipse of the sun in 2017.
Oh,
As a consequence, his middle name is Sagan.
oh, I think we chatted back then about the totality, uh,
Right.
and it was life altering. That was an experience.
Yeah, it really is. And as a result, we're taking him, now he's 6, to a another total eclipse. This one he will be alive to witness, and he's all stoked. So we're
Uh,
going to go to Texas, which is has only a 70% chance of clear view, versus where he lives, which is in the Northeast, where he has chance of a clear view is only 30%. But we couldn't quite get to Mexico uh, for a 90% chance of a clear view. So
uh-huh.
we're taking our chances, but it's worth it.
Yeah, my expectations were so high. I think I told you back then. Um, uh, I really didn't think it was going to live up to my expectations, and it so far exceeded my expectations.
Really?
And it just blew me away, and it still does. I still get what are they? I guess pillow erection.
Is that called
uh,
goosebumps?
yeah, goosebumps, right? And thinking about it, and caught a little bit this last weekend, just down here in LA. Just the light of the morning light of the partial eclipse.
Mm.
Partial ring of fire here in LA. It was it was only up to about 70% or something.
It wasn't worth looking up.
No, but with glasses you could see it was interesting to look at, but
Interesting.
yeah, it was interesting to look at with the glasses, and more interesting was the ambient light of the morning, which reminded me so much of the light that happened before the totality up
Mm-hmm.
in Oregon, and
Mm-hmm.
the light that happened after the totality.
Mm.
So it was sort of the it was reminiscent of the event, but it wasn't
Can you
it didn't
explain
have
why? Can you explain why it exceeded your expectations?
up in 17 the uh it oh man, I had such high expectations because I've been hearing about all these people that travel the world to follow totality, and I thought, God, those people must be crazy. Like all it
Hmm.
is I've seen pictures, but
Yeah.
you cannot see this in pictures or video. You really can't. And
Mm.
I'm a cynic. You've probably heard me in the room before.
Mm-hmm.
You know, I'm I don't make a big deal about stuff. I usually take the uh, dissonant side somewhat, but that standing up on that cinder cone or uh, cinder cone volcano uh, that my friend found that was on BLM land with about 50 or 100 other people that knew how to get up there to that lookout tower, and to witness that. I don't want to spoil it for anybody,
You
but
can't.
one but you really have to see it. And one of the things that really blew me away in the moment of totality, it's really nothing much until the totality really hits, and then you feel a very small place in this universe. You feel connected to, despite being feeling small and insignificant in the celestial, you know, scheme of things. Uh, you feel very present, and you witness a I witnessed a 360-degree view or 360-degree sunset,
Mm.
which is something you'll never see.
Mm.
The sunset was in all directions,
Mm.
and that blew me away. And it
So
really
you were up high. You were up high.
we were up on probably a 1100, 1200 foot above ground level cinder cone butte, uh,
Mm.
you know, um, that and there was no foliage on it. It was all volcanic rock, and it was, and we experienced the full totality back then, and it I was manic about getting there, and I was afraid of traffic getting up there, and you know wanted to leave at 2 in the morning, and after a lot of beer, my friend said, no, let's chill out, we're going to be okay, traffic's not
Mm.
going to be that bad, and traffic wasn't that bad. We got up there, and it was it far exceeded my very, very high expectations. And in that moment, I mean, looking back, I realize why people will traverse the earth to see it again and again and again, because I'm not a spiritual person, but I really get, you really do feel spiritual uh, in that moment somehow.
Mm-hmm.
It's
Mm-hmm.
it's unlike anything I've experienced.
Mm-hmm. Yeah. That's spiritual is the right word for me too. Although for me, I was experiencing my daughter-in-law putting down the phone that she had just called her doctor, saying my water broke. So I knew that
Wow.
as soon as the eclipse was over, I was going to be helping her into a car, and she was going to be driving off into the sunrise, if you will. And shortly later, she was on board a helicopter to Bend because of the traffic. We were not in
Oh,
Bend,
huh. Yeah.
so so it was. But so you didn't experience the traffic. She needed a helicopter.
Uh, Oh, yeah, that was probably a good idea, but, I don't know what the traffic was around Bend because we left early and we drove north, to sure, because I think in Bend proper, there was a sliver of
Yeah.
non-totality.
In
So
fact, we were, yeah. Well, we had a hotel Airbnb that was 10 miles from totality. The
Yeah.
people who stayed at the hotel didn't see totality, and they were rather ho hum about it. And
Yeah,
and I
it
just
is
I
ho
just
hum.
couldn't, I wanted to
Unless
slap
you're
them
in it.
around and say,
Yeah, you can't
"Excuse
be
me."
close to it. You either have to do it or not do it.
That's right. So I had I took a video, but it didn't take a video of the sun. What I took is a video of my daughter-in-law, and essentially that's it. And so what you see is people looking up, but what you do is you can go frame by frame, and literally it was 5 or 7 frames from light to dark.
Oh
It
wow,
happens that suddenly,
wow, that's
you know.
you just nicked it. Yeah,
Right. We only got a minute of totality,
yeah,
and I know that because I could count the minute right on the video, you know.
yeah.
So, but this place we're going to be going to is going to give us something like 2.5 minutes, and that'll be.
Oh, it's whatever it takes. Do it. It's oh man, I might be there with you. So if
Where are
it's
you going to go if you
close
go?
close to a Tuesday, I might have to travel to. Well, I don't know if I can get my my motor coach together that can move outside of Oregon on new tires, then I'll go anywhere that's within 4 or 5 states. In my view, that's my that's my reach.
So you'll bring your hotel room with you,
Yeah, yeah,
right? But the gasoline will be
yeah. No,
the penalty you
but
pay.
I've got a dog, so that's
R- Right.
yeah,
That dog.
yeah. So she, I travel. I travel with dog friendly on 6 wheels. So yeah.
6 wheel. Do you pull the trailer?
No, it's got double wheels on the back.
Uh huh.
It's a vintage motor coach, and it has dualies on the back, so to support the weight of the V8.
Ah. Right. I would love to do that. I did it once, traveling in a
That's
motor
great.
coach sort of thing, and it was fun. But I did it for 2 weeks, not you have it for a lifetime.
Yeah.
So that must be fun. So let me just say to the people here, please invite yourself to the room, to the stage. Frankie is here in order to vamp while we wait for you to show up on the stage. So we're, you know, every week, Frankie, the audience gets smaller and the chances of actually having a conversation get worse and worse. But so I'm going to invite people again to the stage so we can see how that works out. Uh, we do have Carla. Uh, is Carla? You are very brave. You are very brave to come up again. Well, each time I consider you brave beyond belief to come up. So how come you've done it again tonight?
How come? I'm
Yeah.
just out.
Yeah, but the things, Carl, you're interested in saving the planet, right? Basically, right?
Oh no. Yeah, I mean, yeah, yeah, yeah.
Yeah, yes, yes, right. And so, do you think there's any hope for the planet?
Yeah, yeah, I do.
Why are you optimistic? I'm not at all optimistic for the planet. I mean, the planet will be happy without us, but we as a species don't look like we're doing very much to uh, take. We're not good stewards of our planet, and we get worse every year, not better. And although we have some of us have good intentions, like yourself, but the rest of us are including every one of us, are basically polluting the planet beyond belief by our very presence, unless we live, off the grid entirely. And there are very few of those people. Those are the people that will survive, I have a feeling, the people who do live off the grid. Uh, but I don't know that they will survive and have learned a lesson. Imagine that we all disappear for some reason, all but a very few of us. And let's say that something we've done to the planet has made us all disappear, except for a very few. Would you think that the very few of us that are left, and I would not be included, would in fact have learned our lessons so we wouldn't do what we did before again? Do you think?
Unfortunately, I don't think humans ever really learn lessons. I think we're quite doomed to our egos. And however, um, there hasn't there hasn't ever been a time where, you know, well, there were particular societies throughout time that perhaps valued the environment, um, but the large majority of us, of our societies, have not. If that were to change, perhaps we'd still do terrible and stupid things. But if there was only one, if there was one rule, and it was don't um, don't mess up the planet, it might be easier to not do that. Like if that was like the one rule, you know.
I think was just thinking because I asked you what we would do differently the next time. But there is something we would do differently the next time. Let's imagine that 99.999% of the people on this planet left, and so there's maybe just a few hundred of us. Okay, we start over again. But because there's very few of us, we would not be able to use any of the technology that is left behind. Once we've exhausted all the canned goods, we're not going to be able to repower the power plants. We're not going to be able to do any of that. So we will be starting over to reinvent. But the difference is we've already, to some extent, removed from our environment most of the good stuff that we need to pollute. So, for example, iron ore has been thoroughly mined, so that to get to it, you have to dig deep. But you need the machines to dig deep, and the machines won't work, when they finally get around to inventing those machines a few hundred years later, so that nobody will be able to build the machines because they won't have the copper, they won't have the iron, they won't have the coal, they won't have any of the resources that our ancestors had to build the polluting society that we live in. So they won't get anywhere. And maybe that's the answer. Maybe we will not be able to kill ourselves the next time around.
Right, it's a very very positive outlook you have.
Yeah, I just came up with it. I'm usually so negative.
That's perfect. I mean, seriously, if we don't have the tools to destroy ourselves, perhaps we won't.
You
Right.
know, curiously, I watched last night an old movie by Werner Herzog, which I'd never seen, called. Have you ever heard of this? Fitzcarraldo.
No.
Um, uh, it's kind of a bizarre film based on a true. I mean, it's a true story that was recreated by Herzog about this South American. Well, it's an Amazon. Somebody could probably help me if they want to help describe it, but it's this crazy guy European guy who travels down the Amazon uh, to build an opera house deep in the Amazon to create the greatest opera house ever on the ship that he buys, and uh, and you see the Amazon as it was 50 or 60 years ago, and he recruited all the Amazonian natives to help, you know, photograph this thing, hundreds of them, and it's all about this story about this ship being hauled upriver and up and over a hill. It's incredible. You have to watch this movie. It's nuts.
Is it fiction, if you will? Is
No,
it
no, no.
fictional?
It's nonfiction, and it's a retelling of a story that actually about this mad German dude who actually did this, And there's a more perhaps a more famous movie that I think is called it's a documentary called Heart of Darkness or something like that about the making of the movie, which people know more film buffs know more about the making of the movie than the actual movie. Anyway, you see
Hmm.
the Amazon as it truly was, and you see this lush jungle and these native people, and you see their quest for iron, which is interesting.
Mm-hmm.
They have to sell in order to create swords and spears and machetes and stuff. They have to they have to actually attack and behead people to to get iron because they can't dig, they can't dig deep enough, and that
Mm-hmm.
might be the future that you're sort of describing. uh,
Mm-hmm.
you know if the iron doesn't exist on the surface that you can salvage and melt down, then uh, then it's useless, right?
Right. Did you know? I talking about iron. Uh, I recently attended a lecture and a film and a presentation in which the lecturer was explaining how iron is produced, and I did not know this. How do you make iron if you're a primitive society? And what you need to do in order to make iron, if you're a primitive society, is you need to heat the iron ore to a certain temperature to produce the liquid stuff that you eventually turn into iron, right? So, how do you get that temperature? In order to get that temperature, you need to create charcoal charcoal. And charcoal, which can be produced in small quantities, by just burning something in a fire, to produce it in large enough quantities to be able to be considered to be somewhat industrial, you need to create a very complicated burn mound, which is created from thousands of logs placed carefully around and treated with expert care over a period of weeks before the charcoal is eventually made in this mound. This was done around the United States, around the world, in the early days, and such mounds are still found in my neighborhood, I'm told, because they make it here. Uh, uh, Such mounds are still found in order to make the charcoal, which is used to make the iron. In the old days, they needed to make charcoal to make iron. So, literally, the technology was not simple, it was hard. And
Wonder if that's also the case for re remelting existing iron, or whether that's to extract iron
no,
ore.
I
Yeah.
think you still need to raise it to that temperature. Carla, do you know?
Oh, I don't know, but I do have a question of what do we do with old cars? Like, what do we do with them? The hunks of iron. Like, I don't.
Well, I think that in the end, the problem with my little idea about the iron, they won't be able to find it. They'll be able to find it in the graveyard of the cars. They will be able to find the rust, but you still have to convert rust into an ingot, and that still requires that heat. But the rusted cars will be on the surface, so
So
it
you
will be
can,
easier to find it.
so you can more or less like use a specific form of acid to dissolve the iron back into like a usable state.
I don't know the chemistry. I guess you can turn iron oxide into iron with maybe something like electrolysis. I know you can turn aluminum oxide into aluminum by an electrolysis process, but I don't know about that's called bauxite, and and
Okay.
and all those aluminum cans are made by passing electricity through a slurry of bauxite, which is aluminum oxide of some sort.
So is the fabric of our universe held together by magnetism?
Yeah, in some electromagnetism, yeah, it really is. I mean, obviously the atom is held together by something besides electromagnetism, at least the nucleus. The nucleus has its own little story. But once you leave the nucleus on your way out and you encounter the electrons, you're already into the domain of electromagnetism. And that is good until forever, because electromagnetism rules the universe, except that gravity doesn't care about it. So gravity can ignore electromagnetism and make stars and planets. Uh, because if gravity cared about electromagnetism, it wouldn't have a chance. But since gravity is only the plus sign and not the plus and the minus, it can keep gathering stuff together. Whereas electromagnetism can't really gather stuff together. It can just because it's strong, but it's not very good about putting things together. Like for instance, you and me are held together by electromagnetism. But we don't stand a chance against gravity because gravity managed to put together an entire Earth, which, kind of will defeat our electromagnetic forces if we jump off a building. It will be squished by the gravity of the Earth, uh, even though our electromagnetic forces are stronger. I don't know if that was relevant, but
Yeah, sounds great.
yeah, I really think I really the older I get and if, I don't get religious, but I am the more that I think about how well put together I am as in the universe, uh, I'm totally struck by the magnificent design. Uh, the nevertheless, it's simply by the laws of physics, but nevertheless, I think it's wonderful that I have emerged from the laws of physics to be who I am talking about this today. It's Carl Sagan once said, the universe created intelligence for so the universe could observe itself, could understand itself. It's like we are at the very peak of the in time of being and really for the first generation, really, the first generation to really understand ourselves. We are, it is in my lifetime that we grew to understand the little thing called the Big Bang. The Big Bang wasn't real, when I was a little kid. The Big Bang only was real maybe 50 years ago. Before that, we didn't have a clue. Uh, so, so we really know how we got here. I mean, sure, the Big Bang has its mysteries. Not certainly we don't. A lot of people in this room often ask me the same question over and over again. What was before the Big Bang? Was it really a singularity? What does it expand into? They ask those sorts of questions, and the answers are never very satisfying. Those questions are pretty much the questions that I often get in this room, and we really don't have answers to those kind of questions. A lot of hand waving. Nevertheless, I can wave my hand and give you the stock answers, but it's not satisfying. And but I am pretty happy to think that perhaps we will never know the answers to those questions, you know, uh, and maybe we know as much as we ever will about the Big Bang and where we came from. But I am sad that I will not be around for when people figure out how life came to be. I have no problem understanding how we came to be from the first uh, self-replicating life form. I have no problem how we got from then to me. I just I can do it in my head. I'm happy with that explanation. But what I'm not happy with is how we got from zero, meaning no life, to life, which is, if you will, seemed to me a binary sort of thing. Either there is life, and one day there isn't, and then one day there is. Life being defined by the ability to, in fact, replicate what you are. So keep making, if not what you are, something as good or better than you are, because natural selection will make something better than you are. So even if life at the very beginning was not very good at reproducing itself, it would be very good at making better copies that were better at reproducing themselves. So life at some point, what would have been something before life, it would be something that didn't manage to recreate itself in any form. So I imagine that one day, not while I'm alive, they will know the answer to that question. And I think it will be done, personally, I think it'll be done inside of a computer. I think they're going to figure that out inside of a computer. They're going to ask AI to work it out for them. And I think AI will be able to figure stuff like that out. Not the AI we have today, but the AI that we might come across in a few tens of decades, to the point where we actually find a way to explain how those molecules get together. One of the things that's hard is the idea of molecules, like proteins, have this thing they call folding. So molecules fold, and they have to fold in a particular way for other molecules to be able to make use of them and sort of join with them. So the problem of folding a molecule takes an enormous amount of computer power. Ha! I can't believe you did that, Carla. Right. Yeah. The folding of proteins is a very computer heavy business, but one day they'll be able to put it inside the computer and see how it all works out. And I'm sure, not sure, but I speculate that life turns out to be the rule rather than the exception. Carl Sagan, did not know upon his death whether life was the rule or the exception.
Did Sagan explain how entropy begets natural se- natural selection?
No, but I can explain what those. I can use those words uh, in a sentence, and say entropy, natural selection, and life. I can use all those words in sentence. It won't elucidate the problem. But I can. Here it goes. Uh, the entropy is the idea that everything goes towards disorder, right? So uh, things things statistically move towards disorder. There's a very, very small chance that things will move towards order, but the chance of disorder so much rules that disorder is always the rule. That disorder is entropy. And the idea is that in any given situation, entropy increases. The word situation here hides the actual design of the experiment. You design the experiment in such a way that you enclose a certain area, or a certain volume, and in that volume, entropy will always increase. So you are, as a human being, are an organism which is in charge of entropy, and you are pretty much a very ordered organism. And your job as a living being is to decrease the entropy of the molecules in your body to order them in such a way that you can make sense of things and actually be alive. So you, as a living being, tend to decrease the entropy. So what about that? Well, the thing is, you decrease your entropy at the expense of increasing the entropy in the volume in which you're contained. So the net of it all is that you plus the volume you're contained in increases the entropy. If you're enclosed in a particularly small volume, you will die. You need to be exchanging all sorts of gases and foods and fluids with the environment. Hence, you're increasing the entropy of the environment at the expense of, and you're decreasing it in yourself. So natural selection is sort of all about decreasing the entropy, but that the universe itself, including you, is increasing. So there's nothing interesting there, really.
I got a kind of random question about, I guess, entropy.
Yeah, go.
So, is it possible that um, the 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 all entropy is like, 'cause I don't know why I've never taken physics, but I just have this like idea, right? It's kind of stupid, but entertain me or humor me for a second. Um, is it possible that like, you know how like all these elementary particles have their own fields, and that like when you get a certain amount of energy in a field, it gets enough energy to make a particle, and maybe is it that these particles, um, the reason why everything kind of tends towards like, um, is it lower entropy when you start to like lose matter? Is it lower or is it
Well,
higher?
give me an example. I don't know what you mean. Lose
So
matter. What do you
I
mean lose
guess
matter?
I'm just get to so essentially all my question is it possible that like the reason why like entropy changes to where like over time like billions and billions of years you end up with less matter because like these different fields just over time lose energy, so the ability or the amount of energy in these different fields just tends to get lost and to get more particles in these fields like your like your quarks and your electrons and so on and so forth, you need more energy to do that. You know what I'm saying?
Well, not quite, because you said something in the beginning that kind of uh, implies something that I don't think is true, which is you said that there's less matter, uh, and if you add up the amount of matter plus energy in the universe, it doesn't change. So it's not like there's less matter. So when you said that, I didn't understand that.
So I guess like when I say like less matter, like from my like super basic understanding is that like things decay over time.
Right. Well,
So
certainly, things that are radioactive decay for sure. But one of the things that doesn't decay, at least as far as we know, and we keep trying to check it out, is the proton. So while the neutron doesn't decay when it's inside of a stable atom, like salt, like sodium, while neutron doesn't decay, a free neutron will decay, but a proton free will not decay. And when the free neutron does decay into a proton and an electron, it those two things don't decay. So in the end, you don't lose matter. I mean, matter and energy do get interchanged from time to time, but the net sum of the two do not. So I didn't understand your premise.
I guess the premise was like when I watch like I guess like physics videos on YouTube, 'cause that's all I do. Uh, they posit that like in the far like trillions of years in the future, like like all matter that we know of should decay. Like even protons should have a lifespan, even though like we in our short lifespans aren't able to capture the decay of it. Like theoretically, there should be one.
We think
So
that the proton should decay, but no one has ever been able to prove that,
yeah,
and they keep
and like
trying.
my bad, right? Because like I can only imagine that it would just take a super long time that our
Oh,
lifespans wouldn't allow
well, you don't
even our
need a super long
species.
time. You don't need a super long time. All you need is a super lot of stuff. So if in place of a super long time, you don't watch one proton, you watch a lot of them. And if that doesn't work, you watch a lot more. And if that doesn't work, you'll watch a lot more until eventually you watch enough of them so you can see one of them decay.
Kind of how
You,
like they do with what's that experiment where they put a tank full of like some chemical and they look for like neutrinos or something like that, kind of like that.
exactly like that. Exactly
Okay,
like that. But the tank that they use to look for protons hasn't shown a decay of a proton yet. And they think
okay,
it's going to. They think it's. They think it should happen. So it's not like they'd be very disappointed if they can't make it happen.
okay. So I
And of
guess
course, they
like I'll
can't make it happen. They need to measure it, and they haven't measured it. So
I guess
what they
I'll
have is
change
they
my
have an upper
question.
limit. They have an upper limit to the lifetime of a proton. That's what they've got.
Okay, so because we haven't been able to observe it with the amount of of protons that they've used to try to detect it, they kind of extrapolate that into like this is the potential for how long it may take. essentially.
Well, no, it's no shorter than this time. It's an upper limit,
Okay,
a
I got you. I got you.
lower limit to the age of the proton.
Gotcha.
It can't be, or an up, yeah, it can't be any shorter than this, and that's a large number of years. It certainly outlives the expected lifetime of the universe. You can figure out, you can come up with all sorts of uh, answers to the question, how long is the universe going to live? And if you have, and various scenarios come up with various answers, and then the proton seems to outlive all of those scenarios.
So I guess the entropic death of the universe would just be due to everything spreading out and then being too much space in between what's left to cause
Right,
reactions to
but the
do stuff.
protons are still there watching it all happen. Right.
Ah,
Yeah. So
okay.
so the idea, the one of the ideas of the ends of the universe is, okay. So this dark energy thing starts to really get serious, and and so things that were close get pushed further and further away, so that at some point everything is invisible from everything else, and so nothing is unable to communicate with anything, and so the universe is just isolated atoms all by themselves with nothing, no friends to talk to. By the way, when you talk about the end of the universe, they don't always include atoms losing their friends in their molecules. It's really the galaxies that are known to be moving apart at an increasing rate. It is not supposed necessarily that the galaxies themselves will disintegrate, and even if that is supposed, it's not necessarily supposed that the solar systems will disintegrate. And even if that's supposed, it's not supposed that the planets will disintegrate. And then it's not supposed necessarily that you will, if you're anything left of you. So it's dark
You don't
matter
suppose?
expand. Well, it depends where you stop with this supposition. You have to, some different suppositions make different assumptions as to how far the dark matter expansion of the universe will take us, because we really all we have is a couple of data points. So it's really hard, and it's experimental. There's no theoretical explanation for dark energy that I mean, there's still good old Einstein. Einstein wrote a little thing called the cosmological constant into his equations, which, unexplained though it may be, and something he wrote on the back of an envelope with a pencil, could easily be the explanation for dark energy, and still wouldn't explain it at all. It's just like one of those tricks that nature plays on us without an explanation. We may never know what dark energy is. We may continue talking about it forever. We may just have, instead of two data points, which is like a straight line, or three data points, which is a curve, we may get maybe one more, and we'll have a better curve. But we're not going to be able to tell you that 100 trillion years from now, what's going to happen to the molecules inside the planet Earth. That's not up for grabs in any scientific theory that we can come up with in the near future.
That just brought up another kind of super silly question, right? So,
Oh, good.
so dark matter is kind of the explanation for like why it looks like things appear to be moving away from like every direction we look in space.
No, that's dark energy. That's dark
I'm
energy.
sorry, dark energy. My apologies.
Yeah.
So, is it possible that how would let me put it like this: if I am as an observer from Earth, I'm looking into, let's say the Earth isn't rotating and still on this motion, the sun's still on this motion.
Say it
Is
again,
it
please.
that so I'm gonna like kind of make a little thought experiment. So we're gonna stop the motion of the Earth just so
Okay.
we can't say it's like rotating for a second because it's kind of important for the experiment.
Okay.
And I look in one direction of Earth, and then I go to the other side, look in that direction. Go up,
Uh-huh.
look in that direction, go down. Is
Okay.
space expanding equally in all directions?
Yes. Absolutely. You are the center of the universe. Congratulations.
Cool.
And
Cool.
of course, that doesn't mean that I'm not, but you are the center of the universe. And so space is expanding in all directions. You don't, just from you in your direction, you don't, you can eliminate the planet from your, which is what you did. You eliminated the planet, all
Mm.
right? Uh, and so, and then I made you the center of the universe, which is what you were hoping for there. And then the answer is yes. There is, and the words for that are the universe is, and in case you don't know this word, it's a good one. And if you do know this word, then it's the right one. The word is isotropic. Do you know that word?
Yeah. Like same in all
And it means the
directions.
same in all directions.
Yeah, and I know
Universe
that
is
word.
right. So that's what the universe is, and to the best of our observations, it is isotropic. By not only is it theorized to be isotropic, it is also seen as isotropic. No matter which way you look, things are the same at cosmic scales. And not only that, but the universe is also homogeneous. And every now and then the headlines hit the paper that not so homogeneous as you thought before. That just means you got to just take a bigger piece of the universe before you can call it homogeneous. So the universe is isotropic and homogeneous, and
So
you're the center.
from that perspective, like let's say I'm the observer just somewhere out in space. Everything's expanding away, equal speeds. I'm just using speed because I don't know another term to use.
Well, the
Is
faster
that
you, faster away, the further away, the faster it goes. But yeah,
yeah, I got that part. But like I guess the question is that with that view of everything moving away, like isotropically equally in all directions, would that be any different than if like I don't know, like this was inside of a black hole and we were moving towards something? Because it kind of seems like everything should be moving in all directions. I wouldn't say like it should be isotropic, but it kind of seems like that would be the same logic. If there was a hole in space time and moving towards some other point, everything should be moving away.
the problem with throwing into black holes into this conversation is you immediately enter the realm of, okay, if you say so, because we don't know, you know, what's inside a black hole. We know they exist, and we also know that the laws of physics as we understand them don't apply because things are moving faster than the speed of light, and that doesn't make sense, right? So when you enter a black hole, you can't leave again because you don't have all directions are down. No matter how fast you move in any direction, it's all down, which is not the same thing as the universe we currently live in, which in all directions are not like down, if you will, they're just out. But geometry changes inside of a black hole, so it's it's totally unclear what goes on. And so, if you wanted to postulate that we ourselves are inside of a black hole, you're not going to get a lot of argument to the contrary. I mean, it's been proposed, it's been investigated, and and to some extent, it's been uh, people are not sure that that's true. If it was true, if we were able to show that we are inside of a black hole, it would be really big news. What it is small news because it's like it's a possibility, but I can't prove it.
I think that's really fair. I guess the reason why I asked it is because like if you were to consider like if there like let's say like there is like a gravitational anomaly in some direction, like as me and my like from my like reference frame as an observer and moving towards that anomaly, I should be increasing in speed so then everything in the other directions should be leaving me at the same speed. So to me, I can't understand why that would look different than everything accelerating. You know what I'm saying? Like moving away.
Right. Well, let's think about how what happens if you're falling into a black hole, which is essentially what you're talking about, right?
Well, more so like we're already in it. Like the whole universe we know is today was created inside of it. So like
Right.
from the moment we're
Okay.
able to look out in space, it already looks like everything's moving away because we're moving towards something. So things that are because like it's a pull. There's a force being acted, so there's an acceleration going in a direction. So things that are like quote unquote behind you should be accelerating but not moving at the same speed. So it should be like moving. I want to say slower than the things in front of you, but as you're continuing to accelerate, it looks isotropic.
The interesting thing about that idea is that if it's true, then that means there are black holes within the black hole.
Yeah.
And why?
That's interesting. That's true. If we're in a black hole and we have black holes inside of our universe, then there's black holes inside of black holes inside of black holes, which I like. I personally like that. I
Me
like
too.
that, Jake. I'm a fan. You could easily convince me that that's true. I believe in infinity. Okay, so I believe in an infinite universe. Why not?
Yeah, just because we found
It's
one doesn't mean that they aren't all around us.
Oh, no, I'm not necessarily a believer in an infinite number of universes. I'm not a giant fan of multiverses. I'm not. I'm a fan of one universe for us all, and it's infinite. And so and there's no way to tell whether we've got multiverses or one infinite universe or even a finite universe. But my favorite is infinite universe, only one, and and in that infinite
Why?
universe, well, I'll explain in a second. But but in my infinite universe, we have an infinite number of black holes, and in each of the infinite number of black holes, there's an infinite depth, so you can go infinitely far down in each of the black holes. And you could go infinitely far up, where, inside of one. So why not have an infinite number that we're inside of and an infinite number that are beneath us and above us? So, I mean,
But don't you see?
there's no science in anything I've said
Does
except for the fact that I like it.
right? I I adore your perspective, Laird. I really do,
It's
and
it's
it's
it's it's not
it
violate. It doesn't violate anything that we know to be true. It's
right.
just it
But what
can't
we
be
know, but
validated
we know
either.
to be, but you have to admit. I mean, in your heart of heart, you have to admit that the uh, what we know to be true is very little.
Well, on a scale of the kinds of things we're talking about, sure.
Right.
On the other hand, we know an awful lot about a lot of things that are really quite
Sure.
spectacular. But yeah,
From our little sphere, we've learned a lot, and
yeah,
we should pat ourselves on the back.
we
We've
do. I think
come
do.
a
Yes.
long way in 4.5 billion years. Like we've really come a long way, but in the grand scheme of things, it's impossible for us to give ourselves credit for knowing how things are. Uh, uh, when everything, the deeper we look, the less we understand, right?
Right. That is true. That is true. And that's why we build $11 billion telescopes like the James Webb, to give us a little help, a leg up. Sure. And we're going to continue to do that because we need to know the answers to these ridiculously complicated questions that I've just thrown around willy nilly in a few seconds. Yeah.
I
The
just love, I just somehow love how humans are so, they have such hubris and arrogance that they get frustrated by uh, not knowing something. So they have to stick a label on it. They have to they have to explain it. And I just feel like we're still in the flotsam and jetsam of the bottom of the sea, looking up, saying, "Oh, it's all black. There's nothing out there," you know. And in my heart of hearts, we we're just barely starting out. We won't survive long enough, sadly, to be able to answer those questions more than, I don't know, maybe 500 or 600 years out from now. Sadly, but but it is really, it always humors me that we get in these arguments about how things are
Hmm.
when we have absolutely no idea how we are, because we're still just barely crawling out of the mud, right?
Right.
So
No, really, we just crawled out of the mud. We just discovered the Big Bang, which is really crawling out of the mud. It's been about a century since we discovered that the Milky Way is not the universe, and that a century. Before that, we looked up in the sky and said that's all there is. And when we saw these little nebula, we didn't know what they were, and we thought they were inside the Milky Way. And then at some point, Hubble figured it out with the help of a woman, I forget her name suddenly, uh, and they discovered the universe was like big, really big. And yeah, we're just crawling out of the mud. But
And
and and the thing that gets me, okay, because now that I've crawled out of the mud a little bit, is is that the depth of space and time, which is what I'm going to talk about next in a second. But Carla, you wanted to say something? Yes? No?
I just wanted to say this is why women are never remembered for their contributions.
Oh, no, it's because I can't remember. She's no,
Yeah,
she's been remembered.
you
What's
must
her name?
remember this woman's name.
Vera Rubin, I believe. No, or is it the other one? Um, Vera
Nancy
Rubin.
Gray?
What?
Is it Nancy Gray? Or are you talking about the
Nancy.
Vera Rubin, like the
Nancy.
woman that they named the next telescope after?
Yeah, that's a Nancy Gray. Uh, you know, I there are two very important women in in, uh, in astronomy, very important women, and I only remember one of their names uh, at a time, and the one who discovered the universe was expanding by discovering Cepheid variables. Somebody look up Cepheid variables, the discoverer of Cepheid variables, and that they can be used to measure distance. What's her name? Come on, Laird. What's the name? Anyway, I'm sorry, but without her help, wouldn't know the universe existed the way it is, and uh, and and that's only 100 years. And right now, the word for the number of galaxies that are available to be seen in the observable universe is 2 trillion. We now are up to saying that there are 2 trillion in the observable universe, galaxies that have, you know, hundreds of millions to hundreds of billions of stars each. So the universe is just mind-bogglingly bigger than anyone can imagine, and each of those galaxies, having been formed more or less at the same time, and with stars that have been formed more or less at the same time, that 2 trillion galaxies have, let's say, a billion more planets, billion more stars for each galaxy, and each star has, let's say, 9 planets, and so there's an awful lot of planet Earths out there and if life is probable, the joke on the universe is the universe is flush with life, and we will never know it. I think that is one of the funniest things that the universe has ever done to us. It made us so we could, in fact, know that we're not going to ever know and meet anybody else besides ourselves. Because I do not personally believe, given the complications of making one of us, that the universe has many of us currently around near enough for us to meet them, electronically through electromagnetic waves, or and certainly not by flying saucers. So the chances of there being two extant civilizations that could communicate with each other in our own time frame, in our own before we ourselves make ourselves extinct, is probably quite a low probability. I think that is the joke that nature has played on us. That it will always we will always find ourselves to be alone, despite the fact that we're not. You know, it's
Agree.
you agree?
Agree.
Yeah.
It's
Tell
just
me why
math.
you agree. It's just the math. Now, no, the fact is that the Drake equation, uh, the Drake equation is the story behind everything I've just said. It was invented by, Frank Drake, who simply put together a series of probabilistic terms, each multiplying each other serially to come up with the probability that there is, not the probability, the distance to the nearest communicating civilization is a very simple algebraic equation containing nothing more than the multiplication of probabilities, each of which is a number, to come up with, if you will, the distance to the nearest civilization. And you can plug in numbers to that however you like. And I am mentally plugging those numbers in. And for the fun of it, I'm plugging in the numbers so that they work out to be probable and just beyond our ability to see. So, in my take on this, we can see 1,000 light years away. So the nearest communicating civilization is 2,000 light years away, which is not very far, which could mean that our own galaxy could have millions of communicating civilizations, and we wouldn't be able to talk to a single one of them, right? I mean, that's in the best case scenario. The universe has millions of civilizations, but they're too far away. And we can only see about 1,000 light years in terms of our own technology right now. And of course, that technology will change over time. And so these numbers that I'm making up right now could easily change by a factor of 1,000. But that still doesn't mean that they're not, the fun fact that the universe
And
still
that's
has.
and that's unidirectional.
No, no, that's omnidirectional. In other words, the nearest extant civilization is 1,000 light years in some
Right.
direction,
That's
but
sensing.
you get
That's
to.
sensing, but not communicating.
Right, so you could sense. And then, let's say that we're able to talk to one another. Well, that's crazy. If it's 1,000 light years away, then we have to, go back to ancient times to have send our next signal. So we're not going to be able to communicate
Exactly.
unless that story that it's told in Contact is the story, which is why Carl Sagan wrote it that way. He wrote it in such a way that we wouldn't need to be able to communicate back and forth to be able to decipher the signal that would unload the technology of an entire civilization. If we're ever going to be able to communicate with another civilization, it's going to be a one-way communication. And
Right.
and
And so it could be that we, in the future or sometime soon, maybe, we could receive a message, but that message will be thousands or millions of years old.
Right.
right, and the story I'm telling
And
right now,
we'll
it's a
be
thousand
sending
years old.
tombstones.
Right, and those civilizations will we won't know unless they tell us how old they are. So the thing that we want to know more than anything that we could possibly want to know from these putative civilizations, I think I used the word putative correctly, is somebody look it up. Putative, did I use it right? Uh, is that we have one question that we would like to ask them. One question. If you could have one question to ask this civilization that's communicating to you, they're not going to be able to ask them. So we have to hope they answer it. They hope they answer this question: how long have you been a communicating civilization, technological, and if more than 100 years, how did you do it? How long have you been out there? And if
I
you've
think
been
that
out there for a long time, how did you do it? Because we
I think,
we don't have a prayer of being able to do it,
but you would have to know one piece of information, and I think that would be
right?
uh, what is your time frame since the Big Bang? Because that would be the only way for us to tell when they sent the message.
Oh no, no, we would know how when they sent a message. We're not stupid. We would know that. We would be able to pinpoint that message to the nth degree. We would build the biggest telescope ever built to be able to tell us where that message came from. We wouldn't stop till we knew. So there's no way we wouldn't know where it came from. It's not coming from anywhere. It's coming from somewhere. So we would know where that came from. The question we want to know is how old are you? And how did you get to be that old? Now,
But how would
yeah.
we know when the message was sent, though?
Oh, because we know where it came from. It's coming
How would
from a
that?
because you're coming from a particular object in space. So you know exactly how far it came from because you know the object that it came from.
Hmm.
I mean, they would resolve the
We
crap out of it until they figured it out.
we sent them I Love Lucy.
Well, we sent it in all directions, but when they receive I've Let Lucy, they will be able to see that it came from us, planet Earth, so a planet orbiting a star with G2 spectral type. They will know that. They won't have any mystery about it. It's not like it's pervading in all directions. It's coming from one direction. You know,
Well, I can.
light waves traveled straight lines.
Because
So
the
how?
whatever
Oh
the
my bad.
data is that we receive, we would also be able to receive light, which would give us a picture of what it's coming from. Is that what you're saying?
No, I'm saying is that anything we receive would be in the form of electromagnetic waves, which you pick your wavelength, and then it's still light, and then the light is being the light rays are being used to modulate a signal to provide information at whatever frequency, and it's traveling to us in a straight line. If you look off axis, you don't see it. If you look on axis, you see it. You know exactly where it's coming from. You know, you can label the point in space to a certain number of decimal points, and if that's not enough, you build a bigger telescope. And if that's not enough, you build a still bigger telescope. If we're getting data from aliens, we're going to know where it came from.
Well, let's take
So
an example. So you know the wow signal, for instance.
Absolutely. But the WOW signal was in fact received by a radio telescope that was pointed in a particular direction. But
Right.
that wow signal was only there for a short period of time and never reproduced. And
Right.
and they have looked in that particular segment of the sky again, and it never happened again.
Right. So that's what I mean. So we have like a general idea of the direction, right? But we don't
Yeah,
know like with precision where it came from.
I'm
right.
still
But if you
not
point,
convinced. We
you're
know
not convinced
that
what?
uh, we wouldn't know when the message was sent.
Well, if you don't get to see this where it came from, then you wouldn't know when it was sent. True. The electromagnetic waves do not have a time signature on them. True. Although there is some time signature on it because, in fact, electromagnetic waves do get degraded. So if you're able to see a spectrum of the wave, you would be able to know more about when. Because you can resolve distance by looking at the full spectrum.
Well, they must have some idea because like with the wow signal, they generally say it's believed to have come from an area 1800 light years away from us.
Well, that's only because they like to say that, but frankly, it could have come something behind that
Ah,
1800, whatever. It could have come from someplace further away. It's just that
okay.
it makes sense for them to say that because
Gotcha.
there's an accumulation of stars in that direction, and so and things way behind it would be a much weaker signal. So yeah, things close by, the most likely candidate. Now the thing is, let's say that it's real, the wow signal. By the way, the wow signal, for those of you who don't know, is uh, uh, a a very strong electromagnetic signal that was received and recorded and printed out on a computer printout. And the person who looked at the computer printout wrote the word wow next to the measurement. It was the only measurement ever made. It was just one measurement. And the researcher went, wow. So they have, of course, looked again. But imagine that it's real, okay? So what's the problem? The you have to be looking in that direction. Let's just say that it comes from a planet, right? Well, planets rotate, right? If they don't, you're in trouble. They have to, right? Otherwise, you get overheated. So the planet rotates, and as a result, that signal would have been received for a short period of time, which it was. But let's say the signal was sent purposely, then that signal would in fact be being sent, since they don't know we exist, because we were technological only recently, and that signal came from someplace that was further away that could not possibly determine that we would be able to receive and interpret a signal. The people who were sending that signal would have sent it in all directions, not just towards us. Uh, and uh, and maybe it was a mistake. Maybe somebody kicked over the radio telescope and happened to point in our direction for a split second. Maybe it was unintentional. So, there's so many ways that it could be real, but still not be capable of being seen again. And if it is intentional, then they'd have to point it in all these different directions in order to be. And then why are they doing that? What they should do is they should point it. What should they do? All right. Maybe they're highly advanced and they can point this signal in all directions at the same time. Maybe they're capable of that. That's very hard to do. We can't do that with our technology. We'd have to sequentially point in all different directions. But we could do that. We're building a telescope that will be able to scour the universe every few days. So it'll be receiving data from the entire universe every few days. We could reverse the process and send a signal out using that radio telescope, or it's actually an optical
That'd be
telescope.
cool.
But
Let's
it's an
do it.
optical telescope. It's an optical telescope, not a radio telescope. But we could conceivably build a radio telescope that would have nothing better to do than to look in all directions, right? All the time. But we didn't do that. All we do is we occasionally use the SETI telescopes, and we look in one direction or another, and we hope for the best, and we don't spend much money at it. So the chances are kind of slim. And we're hoping that they're sending us a signal, and we're not bothering to send them a signal, right? So we're hoping to interpret not intentional signals, but accidental signals. We're hoping to find another I Love Lucy series out there. And we can't see that for more than, at the best, 1,000 light years. At best. And only if it was intentional. Otherwise, only a few hundred light years, I think.
By the way,
First of all,
Earth is
how do
small.
we understand that that signal is it's artificial? I mean, it probably it's not. It's very difficult to find identify, right? Whether it's
No,
made by any
actually,
kind of.
the way we know is artificial is because it has a narrow band. Narrow band. If it's a wide band, then it could not necessarily be artificial. We are looking in various frequency domains. So if we go from 1 to 1 million in 1 million different frequency domains, and if we find a signal in one of those domains, we go, ah, and does it repeat in that domain? Ah. So it's the artificial nature is because it's concentrated. Natural phenomena produce electromagnetic energy in a wide spectrum, but only instruments like the ones we've invented can produce energy in a narrow spectrum. So that would be a sign of intelligence.
Yeah, that
We
makes
do,
sense.
we do
And
say it was
on
resonant
one more
frequency.
question is there. I mean, it's a if it is. I mean, we are not demanding that as a communication message, right? I mean, maybe they are inventing electromagnetism, that waves probably there is a chance, right? I mean, if aliens are around, intelligence aliens around 100 years, late years from the Earth, they will receive a signal, but it's artificial, but it's not intended for message for aliens. Then also they can able to identify, right?
Firos, are you in outer space because you've got a lot of rocket ships passing by you?
Ah, sorry.
Really, where are you? That the rocket ships are passing by you at supersonic speeds.
Right now in street. That's what.
Yeah. See, right. Sorry, I didn't understand a lot of the things you were saying because of the sound in the background, but that's okay, if you don't mind.
I read that the Mach signal was the happened to be the natural frequency, I guess the resonant frequency of hydrogen.
Right. Well, so what they expect that the so there's a thing called the cosmic cosmic water hole. I think it's called. It's the water hole, and the hydroxyl uh, molecule uh, produces the atomic hydrogen or ionized hydrogen. I'm not sure here. Produces a signal at 21 centimeters. So where they started to look for signals would be at the 21 centimeter frequency because they figured, well, if intelligence throughout the universe has had to agree on a frequency to look at, what would they all choose? So a group of scientists, Carl Sagan, Frank Drake, and many others, agreed that 21 centimeters wavelength would be the choice frequency. So that's where they looked. And that's, but so these days, I guess they look elsewhere as well. But that was the original frequency they all look for. And I don't know to this day what frequencies they choose to do. Anyway, I do want to. So Euro and Jake and Firos and King Kirko. So let's continue this discussion, but let's bring it to another place. Your choice. Where do you want to go?
Well, can I just say something real quickly before we
Yeah,
do that?
you can say it real slowly too.
Okay. So you mentioned Vera Rubin earlier.
Yes,
So we talked about her previously too. So she's known for the galaxy rotation problem,
right,
which led to the
dark,
existence of dark matter.
right. That's right. And I'm trying to think of the other woman who's equally famous, who and also has a telescope named after her. But I'm just losing
I
that name.
I think there might be Henrietta Swan Leavitt
Yes, that's the
because
one. That's the
yeah,
one.
because she came up with the relationship between luminosity and period, and and
Exactly.
that helped Hubble, figure out that the place is much bigger than we thought, and more than one galaxy.
Right, and that's like, can you imagine? So I believe the universe wants us to know about it, and so and of course this is just just me waxing ridiculous, but the if we in order for us to know the size of the universe, we need to be able to step on a ladder and take steps along that ladder to reach the ends of the universe. And the first step, one of the first steps, but not the very first step, because we needed to know the size of our own solar system. So those are certainly steps, earlier steps. Uh, but and being able to tell the distance, say to nearest stars, are also early steps that we made. So we did at some point know that stars were light years away from one another. We learned that. But what we didn't know is how far away certain objects in the sky would be. And so, as far as we were concerned, the Milky Way was contained all the objects of the universe, and they were a certain number of light years away from us. But we couldn't tell necessarily how far everything was from us. And Henrietta, oh God, Leavitt, thank you, uh, she figured it out for us. What she figured out, and as I said, the universe had played a part in making sure that we could understand this, was the universe invented Cepheid variables. A Cepheid variable is a type of star which, at a certain point in its lifetime, does a very magical thing. It it becomes brighter and dimmer. Well, that's okay. Variable stars can do their thing. They burn more or less hydrogen at various times. So a little here, a little more today, a little less tomorrow. So the star becomes brighter and dimmer. It actually does that by expanding and contracting its envelope. Uh, and so, but what was discovered was that the rate at which the star was expanding and contracting was correlated with its actual inherent brightness, which meant its inherent luminosity. So, while I forget the actual relationship, brighter or dimmer, bigger or smaller, the fact is that you can draw a straight line uh, correlating correlating brightness and period. So we were able to measure the distance to certain Cepheid variables, and we were able to note that the brighter ones, let's say, were further were uh, the brighter ones were slower, and the dimmer ones were faster, or the reverse, because I forget. And and once we knew that, what how so you could determine absolute luminosity, absolute brightness on the basis of period, then we could look elsewhere in the universe to see if those relationships can be found in other Cepheids. And we looked at I think it was Andromeda, or it may have been I think it was Andromeda, and which is 2 million light years from us. We know that now, but then we didn't know. We didn't know that it was whether or not it was within our own Milky Way. So what we saw, what we, meaning Hubble, saw a variable star in in Andromeda. And just like the wow think words that were written on that computer printout, he wrote the word VAR exclamation point next to one of the stars that he saw. And that star was a Cepheid variable. And looking at the period of the Cepheid variable told him what the absolute luminosity was. And he was able to measure the apparent luminosity. And now he was able to turn apparent luminosity into a distance now. It had to be further away for it to be that dim. And he knew exactly how far away it had to be before it could be that dim based upon its period. And that gave us the key to the first stepping stone to the rest of the universe. And it was this woman's work, Henrietta, again, I lost her name again, that
Levitt.
Levitt, that figured this all out.
So
So the
out
I
of
think
curiosity, on that.
yeah,
So like
say
out of curiosity, how did they develop a benchmark to say this is the distance we're going to start with because we know this distance to then go and say after these changes are we see these changes and we notice the exact same type of star, there's a difference in distance. You know what I'm saying?
no, I don't. Say it again.
So like to say that okay, so I guess my understanding is you have these separate variables and
Right.
like they can change their like luminosity over time, but then you can get these periodic changes and you see that, okay, these are dimmer, so they're probably further, which I can understand, but how do they initially say we know the distance to the closer one to be able to approximate the distance or the change in luminosity versus the distance?
Well, you can look up in the sky and you can measure the distance to certain stars, the ones that are close. And how do you do that? Parallax. Because the Earth goes around the sun, and it travels 93 million miles in one direction, 93 million miles in the other direction, and so the stars in the sky wobble in the sky if it's close. So if you can find, so you're able to measure the distance to a large number of stars, large meaning a few hundred or a few thousand stars. And some of those were Cepheid variables. So they knew the absolute distance to some of the stars in the sky that were variable. And they were able to tell that brighter ones, a short period or a long period, dimmer ones, the opposite. They were able to tell that directly by measurement. And then they extrapolated that to figure out the rest of it.
You know what's interesting is
Hello.
that we were able to discover accurately the distance to the sun in the 17th century, and then in the early 19th century we got the first accurate distance to a star other than the sun.
Right.
Hello.
And,
Yes.
rapid increase since then.
Hello, doctor. I'm Kalyanama.
Yeah. Kaliana.
Yes, hello. I'm Kalyana. I'm here.
Yes. Welcome.
Thank you, doctor. One question. What do you think about the Earth is flat thing? I've seen many books and I believe in it.
Oh, you do. Why would you believe in such a thing?
Uh,
Sorry,
I
guys.
saw.
Let me just say. So she or he is.
I'm a her.
Oh, you're her. Oh, I'm sorry. Your voice sounds very
I'm a
male.
trans.
Okay, fine. Uh, uh, so the the so we're changing the subject, okay? So because this is interesting, but you will all find that I'm going to have some problems with this because I'm not an expert at refuting this sort of thing, but I'll try. But let's talk. So what is it that you believe, Kaliana?
Yes.
What is it that you believe?
I'm just a girl in from a town, and my
Right. No, but you was talking about flat Earth.
is flat, and one guy told me.
It's what you were
Sorry.
saying. You've been
Yes.
reading
One
about flat Earths.
one person showed me pictures. Yes, one person showed me a picture of a balloon in the sky, and the Earth looked completely flat.
Okay, so that's your but the Earth is round, right?
That's the thing. I don't believe that the Earth is round.
Why would you use your own? Why would you use your own experience to determine whether or not the Earth is flat or round? Why would you do that? Why would you be the? Why would you deny the evidence of people around the world for centuries? And you're saying they're wrong, you're right. Uh, do you
'Cause
think that they're wrong and you're right?
I just haven't proved, like, empirically that the Earth is round because I
Well,
haven't seen it myself.
it's very hard for you to prove the Earth is round. It's hard for you to do that. Okay, it's very hard for an individual without the resources of large numbers of people to determine if the Earth is round. So if you, I mean, you look out at the horizon and it's flat. It's a straight line. It's a straight line. So that's sort of an indication that the Earth is flat. But
Exactly.
that's
Like Emperor
but that doesn't make it
Harun
flat.
wrote, Doctor, it's the same with the Earth is round.
Say again.
That I don't believe in the Earth is round because I cannot prove it empirically. So
Well, you can't, but other people have. Do you accept what they've said?
Well, actually, he can too.
That's the thing. How can I trust them?
Well, because you'd have to imagine that there was an enormous conspiracy perpetrated for the throughout the ages. Millions, billions of people conspired to tell you a story, and they all got together and decided to fake it just so that they could lie to you. You'd have to kind of go down that route of a gigantic conspiracy, or you could go with the other route that you're
One,
wrong.
one question, doctor. Do you believe in God or in religion?
Do I believe in God or a religion?
That's
Certainly
also
not.
billions of people conspire saying that there's a religion and there was God and something. And isn't it like similar to what you're saying?
No, it isn't because religion has no evidence, and the Earth's spherical shape has evidence. So the difference between one and the other is like night and day. One is not fact based, and the other one is.
But how can I prove the facts? That's the thing.
Well, how can you prove the facts?
Yes,
How can you, doing your own experiments, prove that the Earth is round?
exactly.
It may be hard for you to do that. What kind of resources do you have?
I don't think it's hard. I think it's very easy.
Okay, Euro, tell them
A
how.
sundial.
Her, I'm sorry, her. Sorry. Yes.
So somebody just mentioned one way, which is a sundial. Another way is looking up at the sky. The third way is looking at the lunar eclipse.
Right.
The fourth
Well,
way.
she doesn't accept any of those things.
Well, what do you mean? It's up in the sky. You can see it with your own eyes.
Well, okay. Kaliana, do you have you ever seen an eclipse of the moon by the sun, or the eclipse of the sun by the moon? Have you ever seen either of those? Have you? Because when the moon eclipses the sun, oh, she's gone.
She left.
Okay.
Yeah,
Well,
getting
that's
longer.
okay. That's okay. I mean, in truth, it's really wrong for me to try to play in this domain.
No, but
When
it's interesting because I talk to flat earthers every once in a while, and there's a lot of proofs that are available. So we just talked about three or four of them, but there's another very simple one that's been cited for a long time, is watching a ship going out to sea or coming in from sea, and
y-
you see it going over the
I
horizon.
know I know that one, but in fact, the tall sailing ships don't exist anymore. So she'd be really have a hard time finding that.
Well, that's true. Yeah, you got a
Right?
point there,
No, no, but there,
but
but there are good arguments. I'm just not aware. It's not that of course, I've read about these things, but I just don't have them at my fingertips.
well, the lunar eclipse is a really good one. So if you believe that lunar eclipses take place, the only shape that can create that shadow on the moon is a sphere.
Right, but I asked her if she'd seen a lunar eclipse, and she disappeared. Uh, uh,
Right.
what I like is my personal fun one is airline pilots. All right, they take these in order to get to these various places on the Earth. Uh,
Right.
they certain places are very far away, and flat earthers would insist that it's a conspiracy of airline pilots essentially spending extra time in the air just to emphasize the fact that the Earth is round, where in fact they don't have to travel that far in order to get those places. You
Well, they
know.
got another problem too because there's other routes which are much shorter than they would be on a flat Earth. And so you would have to believe that these airline schedules are all fake and they're not really taking
She,
off and landing at the time that they are. Oh, she's back.
oh, she's back. Uh, Kellyanna, did you leave because it said something you didn't like, or you just happened to go? Anyway, welcome back. We are discussing in your absence how we could prove it to you that the Earth is round, and Euro just suggested that sailing ships disappearing over the horizon would be a way to convince you. But we don't have sailing ships anymore that stick their masts up high above the surface. And also, in truth, I spent, a lifetime at the beach, and seeing ships disappear over the horizon is not a thing. It's really hard to do it. The horizon gets pretty misty. You know, it's very rare that a clear day is such that you can actually see to the horizon and see a ship disappear over the horizon. So that's not really a good explanation as to why. I think the uh, the sundial explanation is interesting.
At the
And
sundial, but it requires some traveling. Um, Another thing that requires some traveling is just looking up at the stars in the sky. So in the northern hemisphere, we see one set of stars, and in the southern hemisphere, we see another completely different set of stars.
yeah,
So if those two hemispheres are on the same plane, that would not happen. That's not possible.
I got an idea. Kalyana, this is how you do it, from what Euro just said. Uh, from wherever you are on the Earth, you are at a particular latitude, according to round earthers. And so, if you look up in the sky, you'll find the North Star, and you can point to it, and you can measure the angle that the North Star makes with the ground using a protractor that you've used in high school. Uh, and you can measure that angle. And where I am on the Earth, flat or otherwise, it's 40 and a half degrees. Uh, and so you will be able to do a measurement as well. Perhaps your number is similar if you live in the Northeast like I do. And so then, sometime when you're on vacation, take that same protractor. Perhaps you've traveled south or north. Uh, East to west doesn't work for you, but north south does. And you can look it up on Wikipedia what the what your latitude is. But don't trust that. It could be a conspiracy. Take out your protractor, measure the angle that the North Star makes with your arm with the ground, and measure that. It'll be a different number, and it'll be a different number all night long. If the Earth is flat, then that angle would be different. Could not be different. It would have to be the same. Unless, of course, Catalina, you also suppose that the North Star is in fact somewhere in our own atmosphere, which you would have to believe if you are of a flat earther. You would have to say, because then if the North Star was in our own atmosphere, then as you move around the planet, the angle that it makes would change, despite the fact that the Earth is flat. But it would also change when you went east, west, or north, south. Either any place you move, it would change. Whereas the only place it changes is if you go north, south. So that would be a way for you to tell. And you could do that experiment all by yourself. Uh, and all you need is a protractor and a way to measure an angle. And if
Yeah,
you travel far enough south, you'll be able to do that without the protractor. You can just hold
Kellyanne,
hold something up to the
conspiracy.
sky. Is that
yeah,
right?
that's
So
great.
yeah,
There,
that
there's
that that
one,
works.
there's some other things you can do. You can just weigh yourself, and you'll see that your weight around the world remains the same and only changes in function and altitude and not in location. But
Oh yeah,
if the
your weight will change. But the thing is, she needs a very accurate scale, which is not usually available to the rest of us. If
no,
she
it
goes up,
doesn't
if
have to
she
be
goes
that
up,
accurate because if the Earth was flat, there would be huge differences in weight as you traveled towards the edge of the disk.
well, flat
For
earthers don't believe in gravity. That's one of the things they have to ignore. They have to say that that's not real. It's something else. Electromagnetism they go with, I think, and electromagnetism. So they don't. So they go with the idea that gravity is the same everywhere, and so they don't need that. They can ignore any deviations due to gravity in their what they're talking about.
okay,
I
that's
I think what's real is you took the bait.
Oh, I take the bait. I'm unfortunate. I shouldn't take the bait because what happens is what happens is you can, if you are basically, she brought up the word religion, and religion and science have nothing, no intersections whatsoever, so that you cannot talk science to a person who's religious, and you cannot talk religion to a person who's science based entirely, and that's just pretty much the construct
So
of religion in the
so
first place.
why do it?
Well, that's because I'm stupid.
Why?
No, I think it's good to do actually because, amongst other things, well, for first of all, it's possible that some of these people are sincere, and
No, they all.
Well,
I'm sorry.
it's a
Most.
plea for
I'm sorry. People aren't.
attention.
People are
They need
sincere.
see
well, some of
it's
them are.
it's it's peop it's a ah,
Yes. What? What? Come on, say it.
people
Oh,
Well,
maybe
while
you.
he's
people
thinking,
are desperate for attention, and they will say silly things,
Oh.
and
Oh, you mean like
they will
trolls?
even seek public office to have attention. And
well,
this
that's why I
is our
said some.
society, this is our
That's
world,
true.
and
But
people gravitate to people who need attention, and we're doing it right now by giving somebody attention
no,
that doesn't have any
you're
basis
right.
in reality or science.
Okay,
It
you
just
are.
doesn't make it's not even logical.
Yeah, I know. Yeah.
I think it's a good exercise. Some people are sincere, and plus, it just sort of like makes us think like, how do we know these things? Another thing that you
Yeah.
made me think of when you gave your example of the projector is you could measure your shadows at different places.
Yeah, but that's hard because you need to do it at the same time of day, at the same time of year, and it's all really hard to do, and that's hard. But what I've said
Well,
is easy. But why I jump at the bait? I live in New York City, and people come up to me all the time, from time to time, and they tell me some story of why they need money, and from time and there's various stories that are told, but some people ask for not just a dollar or so. The people ask for money to get home, and that's usually like $20. And over time, I've given $20 to many people, in the fond hope that one of them is telling me the truth. And there's never been a person who's told me the truth, but I'm still not giving up on giving $20 to somebody who's got a new story for me. So I'm of the opinion that she could have been, in fact, not just trolling. That's the word, trolling. You know.
there's two other simple ways that I thought of. One is if you have a watch, you can travel around and you see that you have time zones. And with a flat Earth, time zones don't match with any explanation that explains seasons.
That
Um,
is true. I wonder how they explain time zones.
well, they can't. And then the other thing you can do is you can grab a pendulum, the same way Foucault did, and you could actually just go to museums that have one. Like in the city I live with, they have Foucault's pendulum uh, hanging there. So if you're lucky enough to be near a place that has one, otherwise you can just grab a pendulum and repeat the experiment yourself.
Well, wait a second. You live in Washington, D.C., maybe?
No, I live in Paris.
Oh, I'm sorry, I forgot. Right. Okay. So, and Foucault, in fact, is French, right?
Right.
Uh-huh. Okay. So of course, but I uh, I am a little bit of a skeptic when it comes to Foucault's pendulum.
Oh, really?
Yeah. Uh, of course, it
I think
works,
it
but the
works.
question is, uh, at latitude 40 degrees, does the Foucault pendulum go once around every 24 hours? Does it? Does it? Does it? I don't
Well,
think so. I think the
well,
answer to that
I
is
mean,
no.
right, but it goes around in a certain period of time, right?
It does go around a certain period of time for sure, but even then, okay,
So
and
there's a rotation then.
okay, but let me ask you a question.
Yeah.
You're designing a Foucault pendulum. You've just been given the assignment, okay?
Right.
How do you get that pendulum to keep moving given that there's air resistance?
Oh, well, I mean, I guess eventually it'll stop, but isn't
But
the
how
air
do you
resistance negligible? I mean,
know?
you'll Well, you'll see the rotation before the air resistance causes it to stop.
No, yes, but that's the pendulum spends time rotating all day long for the visitors in the museum,
Right.
and it keeps knocking over these little pins. So
Exactly.
it makes the same arc and the same length of arc, and that's got to be
It
manufactured.
is.
They are
That's,
they are amping they are
it's
amping up
electromagnetic.
the pendulum.
It is. It's
Okay,
electromagnetically done
thank you very much. Now,
uh, at the
since they're
at the.
electromagnetically forcing the pendulum, how do you know that they're not forcing the pendulum in the desired direction? Because in fact, if you're doing it, you have to be choosing a direction to force it in, right?
Well, this is what I'm saying is you could do the experiment
No,
yourself, and
it's perpendicular. The electromechanical pull is perpendicular. It's the Earth that's rotating around the perpendicular 90 degrees of the electromechanical pull.
Are you theorizing or you know
No, I
this?
know this. It's done at the Griffith Observatory.
So you know how they'd actually power
Yeah,
the Foucault
it's a
pendulum.
positive negative alternating uh, uh, push pull of the pendulum. That's very slight,
Right.
very slight because it's a
But
very heavy weight, and
don't you think
but it's done in parallax to the building, and it's not done. It's not. I mean, you could a conspiracy theorists could say that there's a gimbal
yes,
on
I
on
said
that
that's what
mechanism, of course.
that's what
So
okay, in this
all bets
case,
are off if you're going to say that everything's a variable. Yeah.
well, in this
okay, so
case,
I
I
just
don't
looked
know,
it
but I
up.
think it's a conspiracy. I think the Foucault pendulum people have conspired to make us believe that it's really as good as it is. Of course, it works. I just don't think that when they demonstrate it, they aren't, if you will, amping it up to make it perfect.
I understand, but you could do it yourself. You don't have to rely on somebody else's pendulum. And I just looked
Right,
up
agreed.
like why isn't it just stopped due to air resistance? And
Yeah.
so there are actually several factors. It says here that actually minimizes the effect of the air resistance. And one is the mass and shape of the bob. So they make the bob
Sure,
heavy and symmetrical,
reduced. It's big and it's
right?
round
So it
and
stores more energy.
Right,
Uh, And then the other thing is the length of the pendulum. So a long pendulum allows for lower swing angles and slower speeds,
right.
which reduces air resistance. So like the one in Paris, like the length is huge. It's like in this huge building. So I don't even know how many meters it is, but it's like a crazy,
Yeah, so
crazy.
I really would like to know how long it takes the pendulum to, in fact, be slowed down enough so that it has to be, if you will, pushed again. If and I'm saying is they are pushing it ever so slightly every
I, I understand that,
every.
but I'm saying you don't have to do that, right?
No, you
Because
don't. But if you're demonstrating it to the public,
right.
then you maybe do have to do it.
No, I
you
don't
would
think so. It's
no,
gonna
you
last.
wouldn't in a vacuum. You wouldn't have to do it, but
Even
in
in a vacuum, you'd still have some degree of friction.
no, you
Okay.
wouldn't.
In any event, even without the vacuum,
Oh, you would have
and even
friction of the
without,
cable, I guess, on the binding of
Yeah,
the mechanism. You would have a
yeah.
yeah. You're right. You're right.
So there is a time period at which it would slow down, and the
yeah,
question is
but the
how.
point is the time. I'm saying the time period is not significant. It's going to last more than an hour, right?
Oh no, but
The
these things run all day long.
I
this
understand, but you don't. You only need a few minutes to see the
this is
pendulum
Oh
moving.
no, no. I'm not doubting that it proves the Earth rotates. I'm not doubting that for a split second. I'm just
Right.
saying is if you want to demonstrate it to the general public, what you do is you have these little things that it knocks down every
Well, that
time it
well,
it.
that's fine, but we're changing the goalpost because the original question was, could we design something to show somebody that
Oh,
the Earth is rotating, and we
okay.
could
Well,
do that.
in that case, of course, I
Yeah,
did change the goalpost. Yes, you're right.
The
yeah.
I
Smithsonian
did.
website says it would go for a few hours without the assist.
Say again. Say it again.
The Smithsonian website says that I guess they used to have a pendulum at the Smithsonian, and they said it would go for a few hours without the magnetic assist.
Oh, okay, a few hours. Okay.
Right. That's all I'm saying. I'm just saying. I'm saying it is in fact a little bit of a. It's amped up so the general public will buy into it with their own eyes.
Right.
Right. Yeah. Whereas anybody could do it at home. You just have to make a long pendulum with a very heavy bob, and with no wind, and measure the movement, and it will move. It will move. You can do it
Right.
at home.
Well, the sundial's an easy one, but again, it requires you to travel.
No, I'm not smart enough to make the sundial work for me.
Why is that?
Because in fact I need time and distance. I don't know anything about when the sundial should be saying a different thing in a different place. Because
That's
my
why I said you have to travel. You have to be in the northern hemisphere at one time, and then a southern hemisphere at a later time.
but then
Uh,
you have to be at the same time. You have to
no,
trust your.
it doesn't have to be at the same time.
Oh,
Anytime.
okay. Oh,
You just
anytime,
yeah,
as long as
you
you're on the same
you just
date.
have to travel. Yeah, and that's the
Okay.
same thing with like looking up at the sky and seeing the stars from the northern hemisphere versus southern hemisphere. You just have to be able to travel or trust the person at the other end. Um, but in reality, we have all these photos of the Earth as a sphere from NASA and other people.
Well, they've
Now,
been faked. They've been faked.
no, I understand that, but this is my point. She accepts the photo from the balloon,
Oh,
right?
right.
So I'm saying, how come that photo is okay to accept as
Well,
real,
I
but the
think
NASA photos aren't?
the interesting thing really about her, and why, is that there is a certain group of people, large number of people on this planet, who don't accept authority at all, or choose the authority they choose to believe in, and
I get
and
that, but they accept some random person on Facebook who posted a photo
right,
that they don't even know. That's the thing
but
that's bizarre to me. Like, I don't have the problem with the questioning of the
well,
authority, but then on the other hand, to say, well, you know what? On the other hand, I accept as 100% valid some random person at Facebook. I don't even know who they are.
okay, with these same people who believe in, if you will, conspiracies. Uh, I spoke to one person recently who talked about the 13 families. I said, "What 13 families? The 13 original colonies?" And she said, "No, the 13 families that run this country." And she mentioned the Rockefellers and the Rothschilds and like that, and 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 frankly, you and I uh, don't really know whether or not there are 13 families running this country or not. Because you know what? We didn't actually get the news. So she might be right, we might be wrong. We just accept what we know as true, that there aren't, in fact, 13 families running this country. But you do know that there are a lot of people who are running this country that, if you will, do not answer to the popular vote, and they're called not gerrymander. What are the people that influence congressional people? They're the lobbyists. Yeah. So we don't really know how this country is run. So if somebody says it's the 13 families, I don't really have any way of denying that, but she believes it, you see.
Yeah, that's true.
And so,
But that's different from the flat Earth. I know the Earth is not flat.
yeah, but do you know that there's not 13 families running the country?
No, I agree with you. That's different. I don't know.
Right. So the thing is, she accepts the authority of a different group of people, because she doesn't believe in the majority point of view, and she accepts a smaller group of people who say they know. Right, they know. And she feels special because she is part of a minority group of people who know the real truth. You
Right.
know,
I'm just saying
just
she doesn't have a basis to say that. That's the difference.
I know that, but listen. On the other hand, look at me. I'm an astronomer who knows the real truth, right?
Right.
And how do I know all this stuff? Well, I read it. And how do I know that they're not lying to me? Well, I'm going to be have a hard time working that problem backwards
Right.
to explain how come I know what I know to be
That's
true.
that's true. That's true to some extent, but some of it can be shown, and then from that you can keep building if you're skeptical. But ultimately you get to the the question that you raised earlier is to believe otherwise you have to believe that there's this mass conspiracy where
Yeah,
scientists all
there
around
is
the
a mass conspiracy. That's and I think that's it. That appeals to people.
Right, but you just have to think how likely that is versus just accepting reality, because you would have to wonder why is all this time and effort and money spent on this massive conspiracy, over, for instance, the shape of the Earth, which has no connection to power or money. There's no benefit for for that conspiracy.
Look up,
Well,
watch some
that's
videos of
true.
BlackRock. It'll
Say
be
again.
very. Watch some videos about BlackRock and Vanguard.
Oh, that's the Black Rock. Yeah, I should do that right now. And when I get off, I'll look at a couple of videos. Yeah,
Yeah,
I
but that's
will look up Black
the thing.
Rock
The flat
as
Earth to me doesn't make any sense that there would be a massive conspiracy. Like, what would be the purpose of that?
um,
Well, it's
um,
the ownership. It's, if you watch one of these videos about BlackRock, they pretty much own everything. It's crazy. What
Right,
they're
they own everything, but do they own everything because the Earth is really flat and they're hiding it from us? Is that helping them get rich?
yes, no.
I think it's a good question, and we should all examine. Black Rock is the series of videos that need to watch.
Just if you just go to YouTube and put in BlackRock, and I'm sure you'll see some pretty
Yeah,
interesting information.
yeah. Okay, let me ask you all people, how do you think about the future of Clubhouse? Every week, this group of people that I amass gets less and less. How do you feel about that? Is it just me or is it Clubhouse?
Well, as Clubhouse, the changes in the app don't help. I can say that much.
Right. Uh, yeah, is it, I think the changes in the app don't help. Right. So,
Got
so, so the subject right now, because the room is now closed to astronomy and open to your opinions, and you're free to answer this question or others. We will be ending soon, but you can talk about this if you care to go.
I'm just going to reiterate that I still do not see your Twitter link in your profile.
Really? Well, there's no point. I don't tweet, so there's no point in that. But really, it's there. I see it there,
I see it there.
Well, what I see is your Clubhouse name, which
which
might be
is
the same as your Twitter name, but it
No,
doesn't
they're
link. I can't click on it or tap on it. And
no, they're both there.
I
no,
only have I don't have an Instagram link. I only have a Twitter link. It says Laird WH. That's me, as a Twitter.
Yeah, I
And
just clicked on it. It worked.
it did.
Yeah,
Okay. So Jake, I don't know what your problem is. Your interface may be corroded.
yeah, something's up because I see it on other profiles, just not yours. So weird.
That is weird. Well,
you
maybe
don't.
as
Do you see where it says astronomy? Carl Sagan was my doctoral thesis
you see that.
Yes, I see that.
because what's right above that? It says has the little. It has the old Twitter logo with the bird, and then next it has his Twitter name and it's underlined. And if you tap on, are you using an iPhone?
No, Android.
Maybe that's
Oh,
it.
that might be it.
But I do see it on other profiles, though. That's the weird thing.
Yeah, but
Ma-
why wouldn't you be using an iPhone? That's That's kind of
Well, so that's interesting.
that's weird.
I like the iPhone because basically I have it. I personally would have always chosen the Android because I hate the iPhone's inability. I hate the fact that they have a what do you call every app has its own sandbox, and I don't like that. And I really hate the way Apple looks at things. So I personally would prefer the Android, but since I'm never going to switch, I want everybody to switch with me, and everybody join me on the iPhone.
I'm with you on that. No, actually, when I originally had to choose between iPhone and Android, I did choose the iPhone, but I was thinking at the time I'll switch to Android later on, and then of course, I no longer have that opinion. Now
Right.
it's not iPhone for life. But
Yeah, my wife couldn't work an Android, and so we switched to an iPhone. Uh,
I
my
think
wife
it's way
is
better, to be honest.
no, it's simpler. I mean, in some ways because it's stupider, uh, but
Well,
but they really don't let you do things that you otherwise could do. For example, access data as files, and
data as files. What do you
yeah,
mean by?
like my photos, each of my photos is a file, right? Each of my
Right.
photos is a file with a file name and a date and an EXIF inside of it. When I
Yeah,
download that stuff out of my iPhone into my computer, my PC, the stuff
yeah.
comes across wrong, and
By comes
there's no way
across
to
wrong.
fix it. What?
What do you mean by comes across wrong?
The date is wrong. The EXIF has been changed, and and so much is missing.
How come I don't have that problem?
You can down. Well, do you have 10,000 photos from the
I have a
last
lot
10 years?
of, I don't know how many, but yeah.
Yeah, I have about that many, and some come across just fine. But yesterday's photos come across just fine. But try to download something from 2011, and it doesn't come across fine at all.
Okay, I'll try it, but to be honest, I've never had that problem so far.
If you find that you don't have a problem, I want to know the software you're using to
Okay.
do that.
Well, how do you move your files?
Well, I've using the Apple software doesn't work. It does work, but it doesn't work. It doesn't work well enough. And I've tried other software that I've bought and doesn't
Well,
work.
why don't you just use iCloud?
I do. It's terrible. Such a terrible interface. Give me a break.
No, but from the i if it's on your computer, if
Yeah,
you access iCloud, you can
I
you
do.
can move those
I do.
photos from iCloud to your computer.
Okay, first of all, I can't move. I can copy, I can't move. I'd love to be able to move. It's not an option on the Apple. Move doesn't exist. Copy, delete does. But so I can't move. But if when I do copy, it doesn't come across with the right date. It's a different date.
Yeah, that I don't understand. I'll have to do some tests, but I've never observed that.
Yeah, please, if you find that there's something that I don't know, my email address is lairdwh at AOL or according to what it says in my profile, laird at lairdwh.com.
Have you tried it on a MacBook or an iPad?
No, on an iPad it doesn't work because it doesn't give me a file, and it's on my iPad already. And I haven't tried it on a MacBook because I don't use a MacBook. So even if it did come across on a MacBook, it wouldn't be well. Maybe if it did, I'd move it from the MacBook to my computer. I would. I'd buy excuse me, a MacBook just to make it work. I would like to be able to
I think
have
it
my
can work. Is there a reason why you want it as a file?
yeah, because I want to be able to sort by date.
Are you syncing it with iCloud?
I wouldn't sync in a millisecond because you
Right.
don't know what the word sync means.
Well, on your PC, right?
Yeah, I would
Or-
never sync anything. The word sync doesn't mean what you think it means.
Well, you sync, like a photo album to your computer, so it, so
Yeah, but what is sync? If I delete in one of if there's a source and a target, right? And if I delete on the source, it doesn't appear on the target. If I delete on the target, does it delete from the source? That's called
there's probably a
syncing.
sync for that.
What?
There's probably a setting for that, so you
No,
can
there's
say,
not. No, there's not. There's not. There's not.
Well, I,
That's one of the features of Apple. It's not.
I don't know. I'm not experiencing any of those issues. So first of all, like date sorting,
Yeah.
all my all my photos are sorted by date automatically.
On what? On your Apple.
I'm looking at my iPad
Yeah,
and
of
I'm
course
going.
they're sort. No, they're sorted on your iPad for sure. I agree. But when they come to my PC, they lose that information.
"Are you
What?
using Windows?"
No, but what
Am I
I'm saying.
using who?
Windows.
Yes.
Okay, in Windows, you know the columns that you can sort by. One of them is
Yes.
like create date. Well,
Oh,
you
oh,
can.
oh, 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 oh. I know all the other hidden dates. I know about all the other hidden dates. The modified date, the created date, the date you had a birthday party date. I know all those dates. It doesn't work.
Okay, so maybe I'm misunderstanding what you're saying. You're telling me the reason why you want to move them to the PC and have them as files is because you want them sorted by date,
Yes,
but they're already sorted by date in iCloud.
But
I
he
know, but
wants to download them and sort them.
I want to put them on my PC, and then I want to put them on a hard disk, which says, in the event of my death, please save this hard disk. And I want to hand it to my grandchildren and say, here's my pictures. Okay?
Okay, I got that, but isn't the same thing accomplished with iCloud?
No, my, you have to charge my piece. I'm not going to hand my children, my grandchildren, my iPad and say, please, 50 years from now, would you please access my pictures on it?
You don't
And I
have to. You
will.
just say, "Here's my iCloud account."
No, your iCloud account is is not permanent. It's
Well, why
not.
not?
Sorry, it dies with you.
Well, I think Apple has set up a legacy system now,
Yeah, legacy so somebody can download it after you're dead,
which
but
is
not.
what you're looking for.
I'm
I
looking
did
for,
see.
I want to download it myself onto a hard disk
No,
and
I
hand it
understand,
to
but
me.
I'm saying it accomplishes the same thing.
No,
There are discussions online about this issue, and it
yeah,
is an issue where you lose the metadata when you download the images.
yes, you do. And but not only the metadata, also the date on the file date. You'll lose that too.
I don't know. I don't know. It seems to me that I mean, I can do some tests, but it seems to me I can take a photo and just simply save it as a file. It's going to have all
Oh,
the
and you will. If I take a photo today and download it to my PC tomorrow, it will have the right date information,
yeah,
EXIF information. It will.
right.
99% chance it will. But not all of them will do. I've downloaded thousands of pictures and they don't work. They have end up with the date I downloaded it.
Okay.
Not all of them. Not all of them. So I mean, this is you hit my pet peeve, okay? This is my pet peeve. I am a ranting,
I can see you're passionate about it.
right. And if anybody can solve it, believe me. And believe me, I've written to these people who have apps out there, who propose that for $59 lifetime, I can get all my pictures downloaded from my Apple. So I look there and I see that they can't do more than 1,000 or 2,000 pictures. What about the other 5,000 pictures? Well, I don't know. I wrote them a note. I'm expecting a letter any day. It is an ongoing crazy thing for me. Anybody want to solve this for me? I'll bake you a cake. So anyway, so Euro, please, you can see how passionate I am about this.
I
Fix it
am.
for me.
I'm going to look into it, but I'm sure there has to be a solution. I'm pretty confident, but I just I don't know. Like I said, my perspective is a little different. I don't see the advantage of a hard drive versus having it online.
Well, how old are you?
Um, are you saying that younger people don't appreciate hard drives?
No, I'm saying younger people don't think they're going to die.
Oh, I see. No, I no, I understand people are going to die, but I'm just saying that it. it just seems to me that the online solution is the more permanent solution
No, it
than the.
isn't. In fact, look, I've tried. I've spent many hours googling the internet trying to find some place I could put my stuff forever.
With
I
iCloud.
No, you can't. You have to
Why?
because you have to pay, and there's no way you can pay
Oh, for
forever.
free. Oh, okay. Well, that's
Yeah,
different.
not for free. I'll pay. I will. I will devote a certain amount of my money in perpetuity to keeping a website up. Okay. There's no
Gotcha.
way to do that. There's no way to do that. So I want to. I have to take it off the web. The web is not permanent. It's temporary. It may be good for a decade, but not good for the decades that got to live. I'm 78. Maybe I live another couple of decades. Maybe I don't. Maybe I die tomorrow. In which case, I want all that stuff, if you will, on something that has the words "for my grandchildren" on it. And when they grow up, they can look at that stuff.
Then go to Walgreens, print up your photos, and put them in a book, and there you go.
You are correct. You are absolutely correct. That is a solution that I choose not to do. But you're right. I should
Wait, what was it?
spend.
Can you repeat that solution? I missed it.
I should print out. I could literally go into Kinko's and print out
Oh,
color pictures of every single one of my 10,000 photos. Okay, and I could, but you know what? My children will say this is a very heavy load of stuff. I don't want to keep it. Whereas I have something that weighs a couple of ounces that I can say keep, please. Put it in a drawer somewhere in your attic and keep it for my grandchildren. So when they grow up, they can see all this stuff. I'm interested in posterity. That's my thing, you know, because I'm trying to listen. I'm going to die, and I'm not happy about it. And these are all efforts for me to live on forever. I kind of get that there's a certain you don't get out of life alive. So
Another
yeah,
one thing you can do, until you solve this metadata issue, is you can share your iCloud albums with your children, with other people.
my children are very busy. They are not interested. It's my grandchildren I'm trying to reach. Literally. They're the ones who will care. They will care about their grandpa. You know, oh, because I have a grandpa that I care about, and I have some data from my grandpa, and I treasure it. They won't. Children don't treasure their parents. They don't get it how much the parents love them, right? It's only when they have their children of their own that they understand this love thing. Well, my children love their children, but they don't love me anywhere near as much. It's all about passing down the legacy, and that's what I want to do. Pass it down on a hard disk that I download from the iCloud, and I can't do it. You know,
Dr. Laird, this is Jimmy Gumdrops. I just posted in the chat the reason why you can't do it is the file format itself.
let me see the chat. Uh, uh, no, it's not the file. It's not the HEC default format. That's not it. It's not compatible with devices that are not Apple. It's not supported on popular web browsers. And yes, it's not compatible with devices that are not Apple.
okay.
If that's what you're saying, I can believe
That's
that.
what I'm saying. That's exactly
Oh,
what it is. And that was
okay.
adopted in 2017. So you have to use software that will take your pictures, take the metadata, repurpose it into a database, and then pull that all onto whatever disk you want to save it on. I personally use a SanDisk, a 1 terabyte, very rugged, and I transfer it every 3 years. I
Yeah.
solved the problem for myself, but I wish you luck.
No, well,
Okay. I
I'm
think I
not
found
so
the
certain
solution.
that that's the entire problem, but I can buy the fact that Apple doesn't like me.
So I
Yeah.
think I found the solution.
Yeah. Tell me.
Okay. So, because I did some searches online, and this one person is explaining that the problem has to do with the file date and the metadata date in the EXIF file,
Mhm.
and there is an app that will change the file dates to match the EXIF dates.
I know about that app. But you know the problem is that
What?
the EXF date was also wrong. That's
What?
what blew me
How
away.
can
The EX I couldn't believe the EXIF date was wrong as well.
it's wrong in the files that you copied over,
Yeah.
right? But it's not wrong on the originals,
Well, you can't see the EXIF information on the iCloud. You have to download it to see it.
right? But if you took this app,
But the app only converts the app only converts the data in the EXIF to the file date, which is fine, except the EXIF date is wrong
on
in
the ones
some
that
of the
you already
files, not all of
transferred,
them.
what if you did
What?
it on the one before you transferred it?
Say again?
On the ones that you transferred, but if what about on the if you do it on the photos before you transfer it?
But that's on the Apple app. How do I get to the EXIF in the Apple app?
That's what I'm saying. That's what this app does.
This is an app that works on the Apple.
Yeah, it's a
Oh,
tool.
that'd be interesting.
Yeah, it's a tool for Mac OS, and it says here it corrects the dating problem. And I mean, according to this webpage, it solves the issue.
Could let me
But he's using Windows, not Mac
So
OS.
I can send you the page, and then you can be
please?
indebted to me for the rest of your life.
I certainly would be.
No, I'm kidding.
But I certainly would be because I've been working this problem for years.
Yeah,
So it's a serious rant on my part. So if you were able to help me, I'd be fine.
yeah. It says it's a tool for Mac OS, but you don't have a Mac.
Well, my
You might
wife
be able to
does.
run it
My
on your iPhone.
wife has a Mac OS. So yeah.
Okay.
So I could do it if it promises. Okay, send it to me. How are you going to send it to me?
I'll send to you an email.
Yay! Emails, for us old people.
Yeah.
Okay, that's great.
I mean,
Okay,
unless you have an X or IG or Threads.
well, I don't know what those things are. What?
X is a platform.
Oh,
Yeah,
Twitter. Oh,
just send
please
it an
don't,
email,
please
dude.
don't tweet
Send it
it
an
to me.
email.
Please don't tweet it to me. I don't know how to work Twitter. Twitter. I never. I mean, I can tweet, but frankly, it's still a mystery to me.
Do you use Threads or IG?
No, and no.
So I should send an email then.
Yes, right.
Okay.
No,
Here,
social media.
give me
I like TikTok.
if you
TikTok
give me
is my
your email
favorite.
address, I'll do it
Yeah,
right
it's my name, Laird, with a WH because my last name is Whitehill. So it's lairdwh.com, and it's Laird at lairdwh.com.
now. Laird at lairdwh.com. That's pretty easy.
It is. Also in my profile if it's available.
So I think this is right. I'll send you the web page,
Please.
and because it explains it, and then at the bottom of the page they have uh, links to download the version.
Yeah.
And
Yeah.
I don't know. It says there's a free trial available, so I don't know how much they charge or anything like that.
I know it's all that stuff. I know, but and what I do is I often write the manufacturer and ask them what they, if these are my objections. Will it work? And sometimes the manufacturer writes back and says no, and sometimes they write back and say, well, let's see. So I'm
Okay,
currently,
I
we'll
looked
see.
up the price is $24.95,
I can afford that.
but it
But
says it's a 30-day no hassle money back guarantee.
yeah, I'll do it. I'm in.
So
I'm in.
worst case scenario it doesn't work and you get your money back.
No, the worst case scenario is it doesn't work and I don't get my money back.
Yeah, but they said that it's 30
Oh,
days.
I know, but I
Yeah.
know. Anyway, thank you. I'll do it anyway.
Okay. There you go.
And I'll just have to do
Well, I
it. I
hope
have
it
to
works.
attach a hard disk to my wife's machine, which is okay. It's great. Thank you. So maybe this, we've obviously changed the subject a long time ago. Again, check out, I have 9 TikTok videos, which are 15 seconds long. I have 42 YouTube videos under the name Laird Whitehill. Uh, and I have a web page which points to those things, and also to uh, uh, my links that I used for my astronomy course. You can go there. It's lairdwh.com, and I do this every Tuesday. Next week I'll be in astronomy and astrophysics, uh, and uh, and this is what I do. And I appreciate you all being here and playing with me, and especially since we changed the subject. And thank you, Carla, for coming. And I'll see you, and Jake, and Cheryl, and Jimmy. Thanks for coming back. And Kirko, I believe we've just met for the first time. Is that right?
Who, me?
Yeah. No, 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 Kirko.
Oh,
Okay, so thank you all for being here, and I'll see you next week if you
will
can't
you
play.
let me know if it works or doesn't work?
I will absolutely do that. If I get an email from you, I'll let you know what happens.
I
Okay?
already sent it, so hopefully you'll get it soon.
Okay, let's see what my email is Euro. Okay, I got it. Uh,
Yeah, yeah. So just let me know if it works or doesn't work. Because if it doesn't work, I'll have to try something else. But I'm
okay, we
yes.
will play.
All right.
Meanwhile, we're
Blessings.
going to check out these Foucault pendulums.
Yes.
All right, right. Anyway, so what I'm going to do is I'm going to end the room, and so I do it by counting backwards from 10. You can count along, and I'll begin.
Yo,
And
peace
it's
and
10,
blessings.
and it's 9, and it's 8, and it's 7, and it's 6, 5, 4, 3, 2, 1.